Hello and welcome to our live talk on developing skills for Industry 4.0 and advanced manufacturing at Atlantic Technological University. My name is Jean Gilligan and I'm the Head of Online Learning Business Development and Operations Manager here at ATU, and I'll be your host for this live talk. This evening I'm joined by Dr. Corinne Gachon, Head of Transcend at ATU Galway. Welcome, Corinne. By Dr. David Mulligan, Head of Department of Mechatronic Engineering at ATU Sligo. Welcome, David.
Thank you, Jean.
And Darren Ruddy, who is one of our students on the Bachelor of Engineering in Automation and Digital Manufacturing. Welcome, Darren.
Thank you.
This evening we'll be chatting about developing skills for Industry 4.0 and advanced manufacturing. And I'm looking forward to learning all about what is meant by Industry 4.0 and how it can help people to progress with their careers and the programs on offer at ATU. Just some housekeeping before we start. We're not taking questions within this talk. However, if you want to head to the live Q&A section of our virtual Open Evening platform, you can submit any questions there and our team will get back to you. Or you can access the Contact Us section and select the relevant email from there, which will then email our admissions team with your query. So David, can I start by asking you what is meant by the term Industry 4.0 and what exactly is advanced manufacturing?
Sure. Thanks, Jean. So Industry 4 is really referring to the fourth industrial revolution. So if we look back at how industry has evolved, there's been so far three key markers that have happened there. The first industrial revolution was defined by the steam engine and all the potentials that gave us. After that, it moved on to the invention, if you like, of the production line, where we could start to mass produce different products. The third industrial revolution then was marked by advances in the area of automation and electronics. So that brought us up to where we are today. But slowly from there, we have got more and more innovations that have come on stream, especially in the area of embedded systems, with chips and sensors now being on everything, from your home devices that's being produced, to the machines, to the environment and the rooms around us. And this gives us very rich data, and we can use this data to do inline inspection, for example, and that's where, without the product, rather than discovering that the product has gone wrong after the fact, we can actually get the process to correct whatever error is taking place. So you reduce the amount of waste and non-value add products that are there. So that really is where we are. It's really about the information that's embedded in every single thing that's around us and the use of that information to make more intelligent and advanced decisions. That coupled then with the advances in manufacturing or advanced manufacturing. And that's where we have seen a shift in technology moving away from traditional machining devices like mills and lathes to additive manufacturing, things like 3D printers, to 3D print molds that we're seeing taking place. And when we also look at the area of robotics, we see that robots now, rather than doing one routine, they're now becoming more intelligent with advances in the area of artificial intelligence and machine learning. And this gives us new ways of how we can produce products. So when we look at those two combined, we can see a real shift or change in the way that industry is moving for the fourth industrial revolution.
Okay, so there's a lot of advances and changes to everything. So based on that, what skills gaps then are currently in the industry?
Yeah, so if we actually look at the National Skills Shortage list, and there's a list that anybody can look at it online, produced by the state, if you like, as to where we're actually lacking in terms of skills that industry need. And right at the top of those skill sets in engineering across the board has skill shortages, but in particular the area of automation, of robotics, that is a really big skills gap that we're experiencing. But it's not just here, it's a global phenomenon that we're not getting the graduates to the quantity that industry actually need. But if we look at the trends as to where industry is going, it further compounds the problem, because we now need your traditional mechatronic engineers or robotic and automation engineers with advanced skills in the area of 3D printing, in the area of artificial intelligence, machine learning, vision systems, and control engineering with data analytics. So with that, we have built in, and you'll see when you hear from Karine and from Darren, embedded in our programs are those skill sets, not just to meet the existing skill shortage, but also to prepare our graduates to meet the future trends in industry.
And that's very true, because we know now that there are roles that people are doing currently that weren't in existence 5 and 10 years ago. So things are constantly changing and updating. I might bring Karine in, if that's okay. Yeah. Karine, my background is in science and manufacturing, but for someone maybe that's new to this whole area of engineering and manufacturing, and they might be just unsure of where to start, what are their options in relation to studying within the ATU?
Yes, so if someone didn't have a background in engineering or science or in manufacturing, we're very lucky that we have actually 2 programs that give different entry points, I would say. So first, we have a work-based full-time mechatronics system, which is fully online, but it's a work-based degree. So it means students are at work, learning at work, and we find that this is working very, very well. And they study 2 days a week online. So it's very flexible and people can access it from everywhere in the country. Now, we also have, for people that are probably more around the Galway area, we have a more of a blended approach, very similar. So people do 1 day on site, 2 evenings online, and they can work the other days. So it's very flexible as well, but there's 1 day on site to give them the hands-on skills. So that would be a more applied maybe program. But of course, you don't have the flexibility that you would have with the online. So great advantage to have 2 fantastic programs on offer for different kind of students' profile on different needs, I would say.
Yeah, and I'm conscious they're actually accepting applications now. Both of those programs opened in February, and they will remain open till the 18th of August to accept those applications. And we do have, for the work-based learning program, we do have employers that will fund employees currently working for them who maybe have no qualification to get that degree while they continue to work for them. So it's a really good and, as you say, flexible option for them. I might bring Darren in. Darren, you're a student with us on the Bachelor of Engineering Honours in Automation and Digital Manufacturing. And as part of that program, I'm conscious that you'd be working with different types of equipment. Can you let us know the type of equipment that you've got access to and been able to train on while you're on this program?
Yeah, thank you. So as part of this course, we've fortunately been working on all modern and new equipment. So we started off with PLCs. The PLCs we have worked on are Rockwell, the current models, the 5380 or the 5069 family, which is the Compact Logics. Sitting on software version 32 and 33, which would be modern in industry. We'd find a lot of older stuff out there in industry. We're fortunate that it's the newer stuff we have available to us. Then we moved on to, when we go to the industry training module, that's the 1 week intensive training. There is the Control Logics PLCs available to us, which are the next family up as such, or the next level up. They're way more integrated. They can handle more motion and all things that goes with it. And again, they sit on version 32 or 33, depending on which rig we use. Effectively, the software is the same. It's just 1 year newer than the other. Then we moved on to, we also worked on HMIs. The HMIs we worked on are primarily Rockwell HMIs. They're the 5310s, which is the modern ones, directly programmed from the Studio 5000 platform. Very nice to see all modern equipment. We also done motion control, IO-Link, which is another thing that's very relevant in industry currently, and some more motion control on linear slides as opposed to motors. That was also done. There was robots. So there was 3 different types of robot platforms. Fanuc was the first one we trained on. The second one was KUKA. And then we moved on to UR. We've done all 3 of them fairly well in depth. The 2 of them have integrated vision, which is very nice to work with. We also worked on an AMR, which is an autonomous mobile robot. It's kind of the new version of an AGV. Nice piece of kit to see. Very nice to work with. Lovely to get a hands-on feel for it. We also worked on Cognex vision systems. Again, we done a module on that. Something I have worked on for years is the Cognex vision system, but we had an industry expert with us, which was very, very, very good to get his in-depth knowledge of it. I would have had a great working knowledge of this, but the lecturer that gave this course had a very, very detailed knowledge coming from the automotive industry.
Brilliant. So lots of hands-on experience and lots of access to different equipment. And as you say, some that you would have been familiar with, some that was new to you and new programming. So I know going back to education was new to you, and it might have been something maybe that daunted you at the start. But can you let us know the level of commitment or time that's required for you when you're studying for this program, so that somebody that's thinking about it would have an idea of the time they need to set aside?
So as Corinne said there, it was 2 evenings a week for 3 hours, and 1 day a week on site. Now, the 1 day a week on site was all hands-on lab work. On a personal basis, I would have found that very interesting, very nice. Once the lab was completed, we would have typically wrote up a report. From a personal basis, I found I had 90% of the lab report done by the time I actually got home. And I'd sit down maybe in the evening for 30 minutes to an hour and tidy it up just to have it right for myself.
Lovely. David, I might just bring you in on that time commitment piece, because I'm conscious that there may be people, and Darren already mentioned that he was familiar with one piece of equipment, but there may be people that have experience working in industry that may be taken into consideration. And, you know, the time, I suppose, if you're familiar with the piece of equipment, there's less time required to study, but I might just get you to come in there on that time commitment and what's expected of people.
Sure. So when we design the programs, especially for example, for the online offering, the students are often doing the course part-time, which means they're only doing 30 credits in the year as opposed to the full 60. But what we would recommend, because they're working full-time, is that they would try and park 7 hours per module to work on the module. Now, that can be made up of the lecture, it can be made up of doing assignments, going back over recordings. But if they have experience that can in the technology itself, or even in the space. So while Darren was using the Rockwell PLCs, in Sligo we use the Siemens PLCs, and we've got Alan Bradley as well. So irrespective if you've programmed a PLC before, you won't need to spend that much time on those particular modules, so it can be greatly reduced. But to err on the side of caution, if you're brand new to all of the modules, or you're doing something like maths and you haven't been doing it for years, we would encourage that you try and facilitate that. What I would say though, Jean, is that it's quite flexible. With the online model, all of the lectures are recorded, so you can work this into your schedule. So if you're doing shift work and you're working 3 days a week or 4 days a week, the days you have off, you can go back on the recordings and everything is up there online for you. So it is very flexible to build whatever commitment you need to around your own personal schedule.
And I suppose just to add to that, their lectures are all recorded, but it's not mandatory that you attend the live lectures. You can access them at a time that's convenient to you, because we're conscious people have shift work and have various commitments at home. So they can be accessed at any time, and they also can be downloaded, and you can listen to them as you go for a walk, or listen to them as a podcast as you're driving as well.
Or if you want to put yourself to sleep, it's
no, we wouldn't say that. If we just look at some examples, and you know, if I take it the fact that, let's say I was a technician and I had a level 6 higher education qualification, or a further education qualification in the field of engineering, what kind of options are available for me then to upskill, David?
Sure. So as Corinne has already identified there was the work-based learning type degrees that we have in automation and robotics and mechatronic systems. But supposing you want to do it online, and even, Jean, let's take a step back. Supposing you got the Leaving Cert and you went in as an operator to an industry and you've got a number of years experience, it's still not too late. So we build our online programs in particular on the ladder system. So we start off with a level 6 qualifier, and you can do that in the area of electronics. You can do it in automation and instrumentation, depending on where your interests lie. And that's a 1-year 30 to 35 credit, depending on the qualifier that you're doing. And it gives you that taste of what third level education is like and what the online education system will be like. Once you finish that with your years of experience, we can then give you entry into a level 7 degree of your choosing, either in the mechatronics space, the polymer processing, data centers, facilities, electronic and computing, could be manufacturing. There's an endless list there of what we can give you advanced entry into. And that way then you're doing the 60 credits of the level 7 in your BEng, and that will take you 2 years. And then if you finish that successfully, you can go on and do a level 8, and in some fields then do a level 9 as well in whatever your stream is that you choose.
Brilliant. And I'm conscious you mentioned advanced entry, and I might ask Darren about that in a minute, and what that means and how students can avail it. But Karine, I'm also looking maybe for some examples from you with regard to if I was in engineering and in the manufacturing industry, or even a science graduate with a technical role within industry, and I want to reskill within that field. Can you just give me some examples of programs that might be beneficial for me?
Yes, absolutely. So for people that already hold a position, let's say, of engineers or kind of that would have a level 8, we have a higher diploma. So it's a conversion program in automation on digital manufacturing. And it works the same. It's a blended program, and people come on site for 1 day a week. And then they do online 2 evenings a week, and they have a project as part of that. So that allows people to get to build on their own knowledge, their own experience, and get kind of the skills that David's identified earlier as skill gaps in industry. The other one we have to follow on for people for maybe that already have kind of a knowledge of that field but want to upskill. We have a master's, Master's of Engineering in Automation on Digital Manufacturing, and that's a work-based master's. So it means people will try to conduct a project that will be beneficial to their company. So they can do that project, so it's a research projects that they would do in their company. There's 4 taught modules, so 10 credits each. And then there's a 50 credits project. So that would be the options here. Now for people that already have a level 7, they can access a number. So we have a BEng in advanced manufacturing systems that cover some of the skills as well. And that would be open to graduates level 7 from science, from engineering, that would like to get an edge with kind of these digital manufacturing skills. So that's open to science, engineering graduates that work maybe at least 1 year in industry, just to give them that context. And it's a 1-year program on, so it's online on these 6 days, 6 Saturdays attendance on site for practical activities.
Great. Darren, we've mentioned advanced entry, and Karine was just talking about work experience and people having a year's work experience. And I'm aware that you were working within this field, but you may not necessarily have had the qualifications that you wanted. Can you tell us about how advanced entry worked for you, and how you accessed it?
So I came from industry with 18 years experience in the mechanical field. Now, I suppose I had drifted across into the automation field as a result of troubleshooting and stuff. I had interest in it, and I got the opportunity to do it, so I did. But I still didn't have the qualifications to actually say that I am a fully qualified automation engineer. So I wanted to get that. So I joined in year 2. And have completed 3 years since. So as a result of me having relevant work experience and previous qualifications, I was able to join to year 2 of the program and proceed from there. So I'm just coming to the end of my 3rd year as we speak.
Brilliant. And if anyone wants to know more about RPL, we have, you can ask questions, or we have RPL advisors that'll help you. And I'm sure they would have helped you, Darren, in your time.
Absolutely. Yep.
I'm conscious that I think we're coming to the end of our time, so we're going to have to wrap it up. But thanks, Karine, David and Darren, for being our panelists this evening. Hello. There was lots of really helpful and informative information. So if anyone would like to look back we'll be able to upload this video and it'll be on the live talk on our virtual open evening webpage, and you'll be able to watch it back at any time. If you're interested in doing a course from our Industry 4.0 or manufacturing area, you can visit our course search section on the virtual open evening platform, and you can watch academic videos about some of the courses. And if you have any other questions regarding the talk, head over to our live Q&A section. Our team are going to be available there to answer any questions. So thanks for enjoying. Sorry, David, did you want to come in before I go?
Jean, just to make people aware as well that there are, for some of the programs, funding options there as well. So SkillNet Ireland First Polymer in Athlone offers sponsorship on the polymer programs. There's some of our offerings are on Springboard, and there's other funding opportunities to help there as well. So if you have any questions in that area, just please make contact.
Brilliant. And a lot of that information will be on the website, and we're waiting for Springboard to announce. So that's hopefully by the end of this month, we'll know what programs are Springboard funded, and all those applications actually go through the Springboard platform rather than directly with ourselves. But you'll see all of that information on our website. You'll see it on the program pages if they're Springboard funded or if they're SkillNet funded. But thank you everyone for joining us. I hope you enjoyed it and that it was informative for you, and that you enjoyed the rest of our virtual open evening. Thank you.
Thank you.